Alright, here's Alex Schoedler and Jake Nissle's animation project for CS20. I'm first going to show the animation, and then I'm going to go back and explain how the script works and the various modular functions we have here. So, alright, first I'm going to run the animation with loaded points. So a few functions. This one is rotating clockwise. Then we have various reflections through the origin, y and x axes, shearing both directions, scale, and translation. Alright, cool stuff. So let's find out how it works. So basically, the animation is based on, it's driven by one central file here. This is our main script. And in the main script, it calls various functions, which are all only a few lines each, but they all perform various transformations to the points selected. Alright, so it starts out, you have some housekeeping stuff, clear all, close all, and then you have your menu options. So you have a choice to either pick points or load points that you've already picked. In our case, we just picked the points, and I loaded them for this video. So what happens here, if you decide to pick points, it'll prompt you. Here, I'll just do it now. Let's see. Alright, here's the menu. Pick points. This figure pops up, and you can make any design you please. This looks like it might be interesting. And then you hit enter. Right? And then whatever figure you select is transformed in the various ways already mentioned. So while that's running, you'll notice this prep fig function that's called here, and that basically just, as it says, preps the figure window. In this case, it sets up the axis and also the ticks for the plot, which I'll bring back up. And that's all this stuff right here. Alright? So going back to the main script, first thing you see here is this for loop, and that's for the myRotate function. The reason why it's a for loop is because we want the rotation to repeat for 14 intervals until the angle goes from 0 to 360 degrees. So if I wanted to play around with this, which we already have, I would change the loop interval to, let's say, instead of 14, I could do 20. And what that would do is it would plot an extra 6. It would copy and rotate 6 of the points rather than the previous 14. So that's why we have it in the loop. We've changed the font size and also the color to blue, and it pauses, so every 0.1 seconds it'll rotate and plot the points selected. So you call myRotate. This is what myRotate looks like. It's very simple. All it is a matrix times a set of points. And in this case, it is clockwise because we have assigned a negative sign right here. However, if I wanted to make it counterclockwise, I would put the negative right there. Alright? And a lot of how these work, as far as myRotate, reflect X, they're all just matrices that are multiplied by the point set. And in this case, to reflect and transform the design over the x-axis, all you have to do is change this value to -1. For reflect y, you just change that value to -1. So that's like the basic idea of transforming points with MATLAB. I'm going to go further on through this script. We'll see that we have another prep fig. Every time we go through a different transformation, you have to clear it and re-prep the figure window. Alright, so here's reflect origin. We have a blue color for that. Another one here, let's see. K equals 1 to 5, pause 0.2. Alright. And so on. Reflect over the x and y axes. But yeah, I'm going to go to where it changes up a little bit to the shear function here. So here's shear. It's a simple function, a lot like reflect x or reflect y, but instead this time we are adding an assigned quantity to the matrix rather than multiplying by it. What this is going to do is, instead of making the design bigger or smaller by a scale, it's going to move it left and right. In this case, shear x means I'm going to shear it to the x, meaning the x value is going to increase, but the y value will stay the same. Whereas in shear y, it would be the other way around. Let's see, x value will stay the same, but the y value will increase or decrease by some quantity. So going back to the main script, we will see that in shear, let's see, -6.4. Okay, so 4 is that value of k. In this case, we are shearing the design by adding 4 to the x values. However, the y values stay the same. And in a similar sense, we do the same with shear y. So I'm going to rerun the animation just to show how that works. Alright, again we have our rotation. Alright, here's shear. Alright, now that's shearing. If you go into, let's say, scale. For the case of scale, right, we are going to increase or decrease the size of our design by multiplying it by some variable that we assigned in the main script. So in our case for scale, we have decided to multiply all the x values by 2 and all the y values by 4. You could make it smaller by saying, multiply by 0.1 or 0.25. In this case, we want to make the scale larger for our design. Alright. Now, translate's a little bit more complicated, because this time we are trying to not really manipulate or distort our initial design, but instead we're going to just move it somewhere else. And the way we do that is we say, okay, so all the points in the first row, all the x values essentially, we're going to add a number to that, and then with all the y values we're going to do the same. We're going to add a different number, and these will be our offsets, if you will. So you could say, okay, I want to translate this function over 4 units and down 7, for an example. Alright, let's see what else we have here. Translate. Alright, at the very end it'll say cool stuff, the font size of 25 and a blue color. Really, other than that, that's essentially the the basis of our animation sequence. we've done a lot to change the format as well as the direction of some of these functions, like my rotate we've made in the clockwise direction, and then we've decided to scale at different values and shear and translate at different values. So I'm going to run it one more time, and just to give you closing here, no points. Rotation, reflect through the origin, over the X and Y axis, shearing, scale, and translate. Alright, so that's our animation. This is Jake Nissle and Alex Schoedler, and thanks for watching.